Okay, if we want to rotate this noise, for example, in a 2D axis, let me make it more clear what I'm trying to do. I'll just use the whirly noise for now, and this whirly I will decrease the frequency in one axis just to have long lines. And if, for example, I want to rotate this, there's no way to, by using only the whirly noise or any operation after this to rotate it. So sometimes you might want to transform the whirly noise, or any noise actually. Of course, you can use the scale for translating, but as you see that there's a deformation sometimes, and also there's no option for rotation. So what I discovered was that because we have the point data feeding the whirly noise, we can adjust here the geometry, the point data, before using it in the whirly noise. But with that information, we can displace in the original geometry. I'll make this clearer using an example. So basically what I'm going to do is, before having any operations done to the geometry, I will first modify the geometry. I will rotate the points, not by using a transform node, but by using a vector. So first thing I'm going to do is create a vector. I'll just make a float to vect. So basically, without connecting anything, this will create a vector, and I'll make in the component a 1. So x, y, z. So basically what I'm saying is this node creates a vector, or basically a vector is a position in the 3D space. So imagine that this is a value of 1, this distance, and here it creates a point. So it's an axis on the y-axis, an axis on the y-axis. Well, and then after, I'm going to create a quaternion node and connect the vector to the axis. Basically, this quaternion node, there's a lot of information about how quaternions work, but basically it's creates while using an axis which it's defined by this vector, it rotates an angle. So we already have the axis. Now we just need an angle, but we already have published this angle parameter, and I believe it's in radians, maybe instead of degrees, but I'm not sure. But anyhow, with this rotation node in quaternions, I can create a rotate node. I think it's a quaternion rotation, or rotate by quaternions. Yep. So what I'm going to do is take this output in quaternions, connect it to the quaternions. Basically, this is defining the rotation of this node, and the vectors in this case will be every single point from the geometry. I think I can check the results here, and if I see the output, we'll see the same plane, but if I rotate, you'll see that it is rotating, and it's not rotating the object. The object is still the same, but it's actually taking every single point and adding a rotation value. So it's deforming this geometry, although it seems like it's just rotating, but it's transforming in the vertex level. So with this, we can basically feed the whirly noise or any noise we want, and then with that result we can use that displacement that was rotated, but instead of putting into the rotated geometry, we can put it in the original geometry, which is B. If I'll do this, then change the angle, you'll see that now I have a control over the rotation. And good thing is that I can, for example, if this was a different plane, like facing the exact axis, I can change the vector, or I can even change it right now. So it's basically it's rotating. You won't see because there's no visual cue, but this is the most simple case where you have one axis, the rotation is basically strained or locked to this axis, constrained to this axis, and then the quaternion is moving the angle. But you can define which angle by changing the vector here in this float vector. Also, if you have, I believe if you have more, you can this axis can be more than one, of course, but normally I only need one normalized vector. You can also use a normalized node, which basically make this vector to a value between 0 and 1, but in this case it's not necessary. But I think this is very useful in case you want to control in a different way, in a like sort of a 2D way, the rotation of the vector, and instead of trying to figure out how to do it, offsetting it or anything like that. So yeah, I think this is a much better way to do it. Oh, by the way, if just to illustrate this better, if I let me think, if I output this directly, might be visible. No, it's not. Oh, but maybe if I add here the original position. Oh, well, forget about it. Never mind. Yeah, I was just trying to see the displaced geometry, but with the rotation included. In this case, it's not possible. But yeah, I just wanted to show you, how to do it. I hope it's understandable. If not, let me know. I can further explain this part because I thought it's really a good way to rotate this, and using a little bit of geometry with this deformation.